So we kind of you were exposed to these questions a few days ago. We're solving exponential equations. They're more complicated, and a lot of its properties of exponents that we're going to work with. And we can do all of this without a calculator and without a logarithm, and you want to kind of focus in that sense. So when you're doing these, right, when I'm looking at this one here, goal is, from this point forward, rewrite everything in the smallest space possible. Yes, you can use base 4. Just get in the habit of using the smallest space, because in other contexts, it's far easier to work with the smaller base than it is with the larger base. And you're simplifying as you go. Anyway, the base we want to use here is 2. So we're going to write both of the 64s and the 1/4 in base 2. 64 is 2 squared, and 1/4 is 2 to the negative 2nd. All right, so I'm going to do that now. Okay, so the 64 was manipulated here in red, and then 1/4 was manipulated there. And we're going to now work with our exponent properties, right? So we have a power to a power. So first you want to make sure you can just get, a base to an exponent, a base to an exponent, a base to an exponent, and then we'll work on condensing. So that power to a power property, I'm going to multiply 6 and -3. I'm going to multiply 6 and x minus 3. Don't forget to distribute to both terms there. And then when I do that, I'm sitting here now. 2 to the negative 18th x divided by 2 to the 6x minus 18 equals 2 to the negative 2nd. Still work with your exponent properties on the left side here, right? So both bases are the same 2, and I'm dividing, therefore I'm going to subtract my exponents. And when you do this, the bases of the 2, it's always going to stay the same. We're not going to actually divide the 2 there, right? So when I go and do that, it's important that you, sorry, this keeps jumping. If the exponent in the denominator here is made up of multiple terms, just group it, because you are going to subtract, and that subtraction needs to occur to both of those terms in the binomial, and if you don't group it, you're less likely to distribute that subtraction symbol. So we're going to do that, and then we're going to now get ready to solve the equation, right? So both are base in 2, and if this is a true statement, then I can logically just take my exponents and set them equal to each other, right? So set my exponents equal to each other, and then just continue to solve that linear equation, right? Sorry. What's happening here? There we go. All right, so I'm going to set my exponents equal to each other, solve x is 5, 6. You can express it this way. This is usually how it's written. And there we have it, right? Same problem on the other side, right? Same concepts. Use base 3, rewrite everything in base 3. Deal with your power to a power properties where it's necessary. And then once you get down to this line here, then you're going to subtract your exponents, but again, keep your bases the same. So then we end up with 3 to the 3x plus 4 equals 3 to the 5x. Now you can set your exponents equal to each other and solve, and we get x's too. Okay. So again, this is kind of review. We dealt with similar problems earlier in the week, and we'll just jump to more, right? So this is another one. This one's more related to the ones we did last week, but same idea. You have a 1/16, a 64, and a 4. Use base 2. You can use base 4, but I would just use base 2. Makes everything simpler for you. And then, so when we rewrite it in the same base, 2, 2, and 2, this is what we have. And now we're going to apply the power property, power to a power. Multiply those exponents together. Okay, this step, just be careful, right? This is 2 to the negative 8x times 2 to the 6x. Bases are the same. We're going to add those exponents. But when you do this, just make sure, because I've seen a few students here, when they do this multiplication with the 2's, they're calling it 4 to the negative 2x. They're actually multiplying this 2 here to this 2 here. Don't multiply the 2's, just add the exponents. That's the property. Keep the base the same. And then now we set our exponents equal to each other and solve, right? And here we end up with negative half. So again, this is just kind of a review. And then there were a few more, but this one is a little different because now we're going to need to use a logarithm to solve. And this is where it gets a little tricky. Okay, so I'm going to pause the video and start a fresh one.